So in this video, we're going to do some extra examples computing the values for the trig functions of some general angles. So let's start here with example 3. So I want to find sine of 3 pi by 2. So I'm going to graph it. So put it on a plot here. Okay, so that's my initial side. Now 3 pi by 2, so pi by 2 is 90. Okay, so every 90 degrees is 1 pi by 2. So that's 1, 2, and then 3. So I'm going to be on this axis here. Okay, so that's my 3 pi by 2 is this full angle. Okay, so then I could pick a point on this terminal side. Okay, I'm going to pick 0, -1. Okay, that's definitely on there. So then my x value is 0, my y value is -1, and my r value is the square root of 0 squared plus -1 squared, so it's 1. Okay, so that means that sine of 3 pi by 2 is going to be the y value over the r value, so it's -1 for that angle there. Okay, so you could pick any point along that terminal side. Okay, I chose at -1. Okay, let's try another. So here we're trying to find the coterminal angle and then use that to find the exact value of this angle. Okay, so 420 degrees, maybe I'll do it down here. So 420 degrees is bigger than 360. So I'm going to subtract 360 and see what happens. So 420 minus 360, that actually gives me 60 degrees. So that means that 420 degrees is just an extra rotation. So it's going to look like, okay, so 60 degrees is like that. Okay, so that is 60 degrees. So that means that all the way around and then 60 more is 420 degrees. Okay, so sine of 420 degrees is going to be equal to sine of 60 degrees. And sine of 60 degrees we know is √3/2. Okay, so we find the coterminal angle and then we use that to compute the exact value because it happens to be one of our special angles, okay, that we know the sine value of. Okay, so here we want to find the reference angles. Okay, so 9 pi by 4 is equal to 8 pi by 4 plus pi by 4. So that's 2 pi plus pi by 4. So that's a full rotation and then pi by 4 more. Okay, so it's going to look like okay, so there's our initial side. So we're going to go a full rotation and then pi by 4 more. So that is 45 degrees. So that is 9 pi by 4 is that angle there. And you could count as well. So if you break it up into slices, the top has 4 and the bottom has 4. So going all the way around is going to be 8 steps, and then we want one more step. Okay, so that means that this is our reference angle, and it's going to be pi by 4, or 45 degrees. Okay, now -23 pi by 4, sorry, -23 pi by 15, sorry, is equal to So it's less than 2 pi, okay, but it's bigger than pi. So I'm going to take out a pi. So that's negative 15 over 15, so a negative pi. And then what's left over is 8 pi by 15. Okay, so this is negative pi minus 8 pi by 15. Okay, so if I was going to draw this, so I'm going to do it down here. Okay, so we're going the clockwise direction here because it's negative. So I definitely have to go to pi. Okay, so I'm going to go that far. But then I have to go 8 pi by 15 more. So that's a bit of a weird one. Okay, let me just write it up here. So 8 pi by 15 is it's going to be pi by 2 plus some amount. Okay, so because it's bigger than, 8 is bigger than half of 15. Okay, so pi, I'm going to make it over 30. Okay, so this is going to be 15 pi by 30. So 8 pi by 15, that's actually 16 pi by 30. So then I'm going to have 1 pi by 30. Okay, so it's pi by 30 extra. Okay, so we have to go pi by 2 to get to there. And then our terminal side is going to be just a little bit bigger. Okay, so that's pi by 30. So that means that this angle here is our reference angle. And it's going to be pi by 2 minus pi by 30. Okay, so that's if I times it by 15, it's 15 pi by 30 minus, so it's 14 pi by 30, which is 7 pi by 15. Okay. Okay, so that's our reference angle there. So this part, maybe I'm going to get a different color here. So this part here is pi by 30. Okay, and we know that the right angle is pi by 2, so I'm going to take the pi by 2 minus that little bit, and that gives me my reference angle there. Okay, so that was a bit of a tougher one. Okay, let's try some more examples. So suppose I want the exact value of cosine of negative 13 pi by 4. Okay, so 13 or negative, so negative 13 pi by 4. Well, I can take out 12, so I want to take out multiples of 4. So 12 pi by 4, and then I have 1 more pi by 4. Oops, negative, sorry. So that negative 12 pi by 4 is actually negative 3 pi, and then I go 1 more pi by 4. Okay, so if I'm drawing that, okay, so I want to go, so there's my initial side. So I want to go 3 pi, okay, so that's 1, 2, 3 pi. And then pi by 4 more is going to be halfway through that. Okay, so that is the angle, negative 13 pi by 4. Okay, the reference angle here is going to be pi by 4, or 45 degrees. The cosine in that is negative. Okay, so this is quadrant 2. So that means cosine thetas are less than 0. So that means that cosine of negative 13 pi by 4 is going to be negative cosine of pi by 4. Okay, so again, negative, since cosine theta is negative in quadrant 2. Okay, and then we know cosine of pi by 4 is root 2 over 2. So this is going to be negative root 2 over 2, or negative 1 over root 2, whatever you prefer. Okay, let's try cotan of 17 pi by 6. Okay, so again, I'm going to write 17 pi by 6, and I'm going to try and take out as many multiples of 6 as I can, so that there's 12 of them, and then I'm going to have 5 pi by 6 left over. Okay, so that's 2 pi plus 5 pi by 6. Okay, so then if I wanted to draw this, which I normally like to visualize what's going on. Okay, so here we're going counterclockwise because it's positive. Okay, so I'm going to go all the way around, so 2 pi, and then 5 pi by 6 is just a little bit shy of pi again. So it's going to be over here. So I'm going to go all the way around to there. Okay, so that is 17 pi by 6. Okay, so now how close was I to getting pi while I was pi by 6 away? Okay, so if I added a pi by 6 there, I would have had 6 pi by 6, and then I would have had 3 pi. So my reference angle is pi by 6. Now in this quadrant, cotan, so tan is negative. Okay, so maybe I'm going to write that. So cotan of 17 pi by 6 is 1 over tan of 17 pi by 6. Okay, you don't need that, but so I know that in quadrant 2, tan is negative. Okay, so this is going to be negative tan of the reference angle, which is pi by 6. Okay, tan of pi by 6 this is one I don't always remember. So I believe it's 1 over root 3. So it's 1 over negative 1 over root 3. So we get negative root 3 as our answer. Okay, so you could check this. I mean, you don't have to go through tan. You could have also said that cotan of 17 pi by 6 is cos of 17 pi by 6 over sine. Okay, so you could have done it like that. And then in quadrant 2, cosine is negative. So that's cosine of pi by 6 negative over sine is positive. Okay, now pi by 6, cosine is negative root 3 over 2, and sine is 1/2. So again, we get negative root 3. Okay, either way works. Okay, it depends which things you remember as which way you should go. Okay, let's try another one. Okay, so just a couple more here. So if tan theta is equal to 3 and theta is in quadrant 3, we want the value of sine theta. Okay, so let me draw the quadrants. Okay, so we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so we know that theta is in quadrant 3, which makes sense because tan is positive there. Okay, so that's good. So it could look something like, I don't know, something like that. Okay, so that is our angle, theta. So in quadrant 3, we know that sine of theta is less than 0. Okay, so we know that. So we could make our triangle. I didn't draw this very well, but I'm going to make it little here and then make a bigger version. Okay, so that triangle actually looks like that. Okay, and then this is I'm going to write theta, okay, because that's where it would be, but it's actually the reference angle for theta. Okay, so if tan is 3, so that means the opposite over the adjacent is 3. And in fact, these are going to be negative, both of them. So this is going to be -3 and -1, so that tan of it is 3 over 1, which means that this side is the square root of -3 squared plus -1 squared. So that's square root of 10. Okay. So now we have our triangle. So now we know that sine of theta, so we can use the reference triangle, it's going to be negative for sure. Well, I put the negatives on this triangle, so you could just say that it's the opposite value over the hypotenuse value. So it's going to be -3 over root 10. Okay, so that would be the sine theta value for that one. Okay, now in 12, so we know sine of theta is less than 0. Okay, so let me just say, so in that, so sine is negative in quadrants 3 and 4. Okay, tan of theta is less than 0. So that happens in quadrants 2 and 4. Okay, so that means where they overlap, okay, I see 4. So that means we have to be in quadrant 4. So theta, I think I actually want to write the terminal side. Of angle theta must lie in quadrant 4. Okay, so just knowing the signs, so you could make a little grid here. So here they're all positive. Okay, so that one's out. Here we have sine theta would be positive. Okay, so that one's out. Here, sine of theta is negative. Okay, that's good. But in this quadrant, tan of theta is positive, so that's out. And then down here, sine theta is less than 0, as is tan of theta, because this is the quadrant that cosine theta is the one that's positive. So with that information, we already know that the angle has to be in quadrant 4. Okay, so there's lots you can tell just by knowing the sign of the trig functions. Okay, so those are some examples, computing some trig functions at some more general angles than just our special few.